In this video, let's talk about Ubiquiti UniFi's roaming and fast roaming settings. If you have multiple access points, you may be dealing with roaming every day already. If you want to have better, faster roaming, you may want to pay attention to several extra settings in UniFi network controller. For example, the BSS transition and the fast roaming setting. Unfortunately, there are hardly any official documents from Ubiquiti about those settings. If you search the internet, the only things you can find are the confusing historical web forum articles. Some of them were either outdated or were talking about something totally different. This video will have three parts. First, let's talk about the confusing history for Ubiquiti to support fast roaming. Let's talk about how I use Wireshark to capture the Wi-Fi packets. And then in the third part, let's talk about how these two settings impact how the AP communicate with your Wi-Fi clients and how it will lead to different standards to be applied. In the early days of UniFi access points, Ubiquiti supported something called Zero Handoff Roaming, or ZHO. This technology, in my understanding, is simply an implementation of the so-called single-channel architecture. I show you an article from Wikipedia. In this type of architecture, your multiple APs join a virtual cell, and they share the same BSS ID. The apparent benefit is, as is mentioned here, zero handoff time for roaming clients. And the apparent disadvantage is it requires all the APs to use the same channel. It will lead to serious interference problem. So that's why even Ubiquiti, you can see from this article, Ubiquiti already didn't recommend the usage of zero handoff even multiple years ago. Several years ago, Ubiquiti introduced a new technology called fast roaming. This article, you can see the URL here, was referenced many times on internet forums when people talk about fast roaming for Ubiquiti. Unfortunately, for some reason, Ubiquiti removed it from its website. So now if you try to find the link, you won't get it. Thanks to internet, we have a thing called web archive, so we can still find the historical web pages even if now they are not accessible anymore. This is what I get from the web archive. As you can see, Ubiquiti mentioned how its fast roaming works. Depending on your AP's security setting, for example, if you use WPA2 Enterprise, there are totally 17 steps to complete a roaming for a client. This is the root cause for slow roaming performance. Of course, to achieve fast roaming, the steps need to be eliminated or combined. So Ubiquiti came up with its own way to reduce the steps. I won't talk about the details. If you're interested, you can still try to find it from web archive. So this is the help document from Ubiquiti. At the same time, there's an article on community.ui.com. It seems to be official Ubiquiti document because it's under releases tab. The title is fast roaming on UniFi. Basically, it talks about the same thing as the left side help document, but there's some very interesting additional information. See here, UniFi fast roaming is not a direct implementation of 802.11r. It's inspired by the IEEE standard with a few key proprietary differences. That's the root cause for most of the confusions, because on the UI now, even today, if you check your network controller, you can still find the fast roaming setting. See the tooltip? It is for the 802.11r IEEE standard. So why here Ubiquiti said it's not the implementation of the international standard? Ubiquiti never has any official document to explain that. I'm not very sure whether, because this article was released 6 years ago, so maybe something's changed, or maybe Ubiquiti still has two versions of fast roaming, one for the IEEE standard, one for its own implementation. Only Ubiquiti can answer the question. After further digging into Ubiquiti's forum, I found this thread And there were two answers from Ubiquiti. One says UniFi fast roaming is used regardless whether the fast roaming box is checked or not on the UI. And the fast roaming in the UI refers to official 802.11r support. So my understanding, this reply implies no matter whether you enable fast roaming on the network controller or not, the internal Ubiquiti's fast roaming implementation is always enabled. And if you check the other answer, they were seriously considering enable 11K by default, even without 11R. This is interesting thing. We are going to explore 3 different IEEE standards regarding Wi-Fi and to see how and when they are supported by your UniFi AP. Of course, the first thing is 11R, which is for the fast roaming itself. The official name is FT or Fast BSS transition. The other one is 11K mentioned by Ubiquiti. So basically the 11K is for the community report. It's for AP to help your client to understand the current environment. Then there's another one, it's called 11V, that's related to another setting on your UniFi controller for BSS transition. As is mentioned in this Wikipedia article for 11V, it enables WLAN to send messages to the client for better APs to associate with the client. So again, it helps your Wi-Fi client to know better about which new AP to associate with. In this video, let's do some our own testing to see how they are supported, considering we really do not have any official UniFi documents to explain the details. In my lab environment, I use 2 UniFi access points. They are at 2 different locations. I use a MacBook running sniffer application just to sniff the Wi-Fi traffic for access point number 1. Then I use a iPhone. Initially it's connected to AP2. Then I walk to location 1 from location 2. So the iPhone is supposed to roam from AP2 to AP1, right? Then I capture the Wi-Fi packets. Later I display the captured information using Wireshark. Let's check the Wi-Fi packets to see whether those 3 IEEE standards, whether they are supported or not. Because we are interested in these 2 particular network controller settings, fast roaming, BSS transition, so I will use 4 different combinations to test them out. Let me go to the network controller, click Wi-Fi. So see, I defined 4 SSIDs. If you check the first one, Z none, as you can see, I disabled 2.4 GHz just to use 5 GHz to simplify the testing. For the 2 settings, both are disabled. If we check ZFR, means fast roaming, I only enabled fast roaming but disabled BSS transition. And let's take another look for the ZFRBT. In this particular one, I enabled both, right? And of course, for the ZBT, I only enabled BSS transition and I disabled fast roaming. By the way, for all of them, for authentication, I simply use WPA personal. You may know fast roaming mainly is used in, let's say, office environment, and people use the WPA enterprise, right? But fast roaming also works for WPA personal authentication, so it doesn't matter, because in this video we only want to test whether it's enabled or not instead of measuring how fast the roaming is. So I simply use WPA personal here. We have these 4 SSIDs set up. Let's test them out one by one. I prepared this spreadsheet for the 4 different SSIDs. I list out the UniFi controller settings here, and then I will check the 3 IEEE standards one by one to see for each SSID whether they are supported or not. Okay, let's jump to the testing. I'm going to use 2 different Apple devices for this roaming testing. The left bottom corner one is a MacBook Pro. I'm running the Wi-Fi signal strength application. In the bottom right small window is the screen capturing for my iPhone. I'm running UniFi's Wi-Fi man application, and then in the top left, you see the real-time network controller topology. So you can see which access point the iPhone and the MacBook Pro they are connected with. In the top right window, you see another Mac machine, which I use to run sniffer application to capture Wi-Fi packets. By the way, I won't talk about how I do the WLAN or Wi-Fi packet capturing. If you are interested, check my another video. Okay, now I hold the MacBook Pro and iPhone. I walk from AP2 to AP1. As you can see, for both MacBook and iPhone, the Wi-Fi signal strength, they are dropping, but apparently MacBook Pro is more sensitive. Now it's reaching a point. It needs to roam. So let's see which one roam first. Okay, as you can see, it's a long wait time. By the way, for this particular testing, I'm using the Z9 BSS ID, which means none of the fast roaming features are enabled. Still a long wait. Okay, as you can see, the sudden jump from iPhone. So the roaming is successful, and even from UniFi controller, you can see iPhone is connected to AP1, right? Give it some time. Okay, so now the Wi-Fi signal strength is high again, and from UniFi controller, you can see MacBook Pro is also roamed to AP1. So both roamings are successful. I will stop the sniffer application in the top right corner in that particular Mac machine so that I can save the file. Later we can view the captured packets in Wireshark. I have the full captured file saved in this folder. We are ready to use Wireshark to open them. I'm going to fill in the blanks for the spreadsheet. So let's see for different SSID, what are the standards supported, right? But before opening Wireshark, there are still two more things I want to mention. First, what type of packets we want to look into. The packet we want to check is the so-called beacon frame. I opened the Wikipedia article for beacon frame. It's the WLAN management frame. It contains all the information about the network. That's why we want to just check beacon frame. Theoretically, if you check other frames, you may also find the information, but beacon frame is the one broadcasted by the AP, so it will be received by your Wi-Fi clients first. That's the first thing. So we want to check beacon frame. Second thing, remember we have the one AP with 4 different SSIDs. If you check the UniFi controller I opened in the left side, for all the 4 SSIDs, they have the exact same channel, same width. So if you are familiar with Wireshark and Sniffer, how it captures the WLAN packets, you may know you need to monitor a particular combination of channel and width. As long as you listen to this 149 and 40 in my case, you will be capturing all the SSIDs packets, not just the one you want. For example, even in my case, I want to test Z9, but when I capture the packets, in fact, I already captured all other SSIDs packets. The reason I want to mention this is in my test, I captured 4 files, right? But theoretically, I don't have to. Just one file is enough. Okay, those are the 2 things I want to mention. Now let's start Wireshark. Let me first open the captured file for SSID Z9. For this SSID, I have both fast roaming and BSS transition disabled in UniFi controller. Let me open it in Wireshark. This is what you see when you first open the file. It's a super long file with a lot of information which you are not really interested. So how you only see the ones you want? Let's get the SSID's MAC address, the BSS ID. The way to capture it is get it from the UniFi controller. You see under the WLAN for your AP, it lists the BSS ID. Copy it. In Wireshark, you see WLAN.SA equals to the BSS ID or MAC address you just copied. SA means source address. You see it only displays the packets sourced from your AP. For destination, you can see the initial several packets, they are all broadcast, and see the info, they are beacon frame. Those are exactly the ones we want to check. We are lucky, just the first one should do. Let me click on it. Remember, we need to check the 11K, 11R, and 11V, right? Let's start with the 11R, the real fast roaming standard. The way to verify whether it's supported is very tricky. You will see if it is enabled or it is supported by your AP, you are supposed to find it under IEEE 802.11 wireless management under tagged parameter. There should be a tag. It's called mobility domain, but if you read from beginning to the end, you don't see it because we are checking the SSID ZNAN, which doesn't have the fast roaming enabled. That's why we don't see the mobility domain. The 11R standard is not supported under this setting. So we already have our conclusion for 11R. Later, for the other SSID, you will see the mobility domain when they are supported. Let's check 11K. So 11K is so-called neighbor report. It's under another tag called RM enabled capabilities. If you expand it under the octet 1, you see this flag, value is 1, the neighbor report enabled. So which means under this ZNAN SSID, 11K is supported. Remember I show you a 3-year-old UniFi's web post answer. It says Ubiquiti was seriously considering enable 11K no matter whether you enable 11R. This finding means Ubiquiti already done that. So even for ZNAN, I have both fast roaming settings disabled. I still have the 11K supported. Let's move on to 11V, which is for BSS transition. Remember we disabled BSS transition, right? I expect to see it's disabled or it's not supported. Let's see whether it's the case. That feature is under another tag. It's called extended capability. Under the octet 3, see this flag? BSS transition. It says not supported. Exactly what we expect. For the first SSID, we've done all the 3 verifications, and here is the result. 11K enabled no matter whether I enable 11R or not. 11R and 11V, they are disabled. Just like what Ubiquiti replied in the web forum. On the UI from network controller, the setting you make for fast roaming is for the IEEE standard 11R. It's not for Ubiquiti's own fast roaming implementation. So we are done with ZNAN. And for the other 3 SSIDs, most paths are very similar, so I don't want to waste your time. I will directly tell you the results, but only for the 11R. Remember I mentioned it's tricky. We even didn't see the tag or section for the first SSID, right? Let's go to the very last SSID, ZFRBT, which has both settings enabled. Let's see what the 11R tag looks like. This is the Wireshark. I already filtered on the MAC address. I click on any beacon frame. If you expand the IEEE 802.11 wireless management under tagged parameter, this time you see a tag called mobility domain. Remember, we even don't see it in the ZNAN SSID, right? We see this tag here because this is the ZFRBT SSID. We have the fast roaming enabled. So let's see what says inside. See the very first value? That's the one we want to talk about. This value itself is also a little bit tricky or difficult to understand. You see the value is 0. You may think, oh, 0 means it's disabled, it's not supported, right? No, it's not the case. Here, as long as as you see the mobility domain, that means 11R is already supported. It simply says what type of support. Ubiquiti's implementation is 0. 0 means it's not over DS. There are two types of fast BSS transition. One is over DS. DS means distribution system. The other one is over air. Over DS means, let's say in my case, the iPhone is roaming from AP2 to AP1, right? Over DS means the communication between AP1 and my iPhone is not directly done between those two. It's done by using the original AP, which is AP2. So it's done by the distribution system. Over air means it's get the information from the new AP. So see here, it's 0 means it's not over DS, it's over air. Okay, that's the only thing I want to explain. Okay, so let's briefly go through the results. For the SSID ZFR, as expected, 11K is supported, 11R is supported, 11V is not. And for ZBT, 11R is disabled, 11V is enabled. For the very last one, because we have both UniFi setting enabled, so we have all green results. That's expected. So basically the interesting finding is for 11K, no matter what you set on your network controller, it's always enabled. And for 11R, the setting on the network controller is for the IEEE 11R standard. Okay, I know this is a little bit long video. Thanks for watching.